So we know how a capacitor discharges as this kind of exponential decay, but we can also look at maybe how a capacitor charges up in the first place. And again, we can maybe can consider maybe the current in it, the charge stored, and also the potential difference. So first of all, perhaps we just have a very simple circuit, just a cell, a capacitor, and a switch. And what we can look at is how maybe the current changes once that switch is closed. Well, first of all, there's going to be a massive flow of the electrons which come from the negative end of this terminal, and they're going to move around towards the positive end. And as there are more electrons which are moving around, there's going to be a build-up of negative charge on this plate, and a sort of equal and opposite charge of electrons which move around here. And actually, as more electrons flow, there's going to be less incentive for them to get to this plate because there's already going to be a negative charge here. And what we find is that the current actually still has this exponential decrease. And what this means is that as time goes on, the amount of current flowing around the circuit decreases, just like we had before, and therefore we can say that at any point the current is equal to the original current I0 times e to the minus t over tau, where tau is just this, effectively that's equal to CR, and that's the time constant for the circuit. But what happens to the charge? Well, as time goes on, the amount of charge actually builds up, and what we get is this kind of line here. So this might be perhaps the charge, and also as time goes on, the potential difference across this is going to change as well. Now effectively this might have a certain perhaps potential difference across it of V0. We can maybe look at the potential difference across the capacitor plates, which is Vc over here. And this is actually equal to V0 multiplied by 1 minus e to the minus t over tau. Okay, and effectively when this is 1, this is 0, and when this is towards 0, that's kind of increasing to sort of 1 effectively. And therefore what we have is this equation here that tells us the size of the potential difference across this. And effectively when, as t gets bigger, this is going to be a smaller value, and therefore that's where the value of Vc tends towards the original PD of the charging supply. So this is a bit about charging capacitors, okay, which is slightly different to the graph of a discharging capacitor.